It's Mr. Rops,
Mr. Song?
and now we're going to do applications of right triangles. And well, I want to find theta, the acute angle between the x-axis and this line. It doesn't look like there's a right triangle there, Mr. Song. What's this talking about if we're doing applications? Where's my right triangle?
I see one between the x and y intercept and the line.
Ah, okay, the x and y intercept. Here's a big giant triangle, yep.
Yeah.
All right. Now, I could also, to find this angle, I could use, so this distance here is 4, and that distance there is 6. So that could help me. I could also use my slope somehow. I know slope, and I'll do this in a different color, is purple. Slope is rise up 2 and run 3. Rise 2, run 3, which is the same thing as running 3 and rising 2. So here is a triangle where this is 2 and this is 3. And slope always works for us to find triangles because it's just by the essence it makes a right angle. And so if I have this triangle now, where this is theta and this is 2 and 3, what trig ratio can I use to get theta?
Well, theta is in the bottom left corner, and 2 is the opposite side, and 3 is the adjacent side, so we have to use tangent.
So the tangent of theta is 2 over 3. And so if I want to find theta, I can't just go tangent. I have to go second tangent, which is the inverse function. I'm doing it backwards, finding the angle. 2/3 is the ratio. Theta is the angle. And I get an angle of 33.7 degrees to 3 significant figures. Okay, let's try some more apps and see what happens. Oh, 3 quick circle theorems. Here's circles and some tangents from them. Let me call up one of my things that I know for... Here is one of the theorems where AC is a diameter going through the center, which is key, and I'm concerned with angle B. And right now it looks like angle B is 90 degrees, angle A is 48. But if I take B and I rotate it, A is changing, but B is constant at 90 degrees. And so when I have across a diameter, an angle here is always 90. So that's one of our theorems. I know that this value, because it goes through a diameter, this is 90 degrees. And so now I have a right triangle, all my trig stuff works. The next theorem is if I have a radius and a tangent here, tangent means it just touches the circle once, it makes a 90-degree angle. And finally, well, what's this angle going to be here, Mr. Song?
90 degrees.
Right, same theorem as over here. This angle here?
Also 90 degrees.
Right. And so this theorem is showing is that these are both tangent to a common point outside. It means these lines are equal in length. And so that's another theorem that we know. 3 quick facts about circles. Let's see if we can actually use them now. So in this problem, I want to find theta, this angle here. Well, B is on the circle. This is diameter. So I know for a fact I have a right triangle. So trigonometry works here, as does Pythagorean theorem. I have the radius is 6, so this is 6 here. What's the whole diameter of the side going to be then?
It should be double that, so 12.
Right, that's 12. And AB, we're told, is 6. So if I want to find theta, I have 6 and I have 12. Which trig function is that going to be, Mr. Song?
Well, side AB is the opposite, and the diameter is the hypotenuse, so it must be sine function.
Right, the sine of theta is the opposite over the hypotenuse. If I throw this in my calculator, I'm looking for the angle, so I go second sine of 6 divided by 12. I end up with 30 degrees exactly. And so there's an application of using circles and trigonometry together.